Okay, this is Henry again. I'm going to be going over some of the key points from today's class about how to model your stick and wire models using Rhino and Grasshopper. So you can see here that I've set up 3 wires, wire 1, wire 2, and wire 3, using the technique that we discussed in class. For wire 1, I've measured 2 points starting at 0, 0, 0, and then 1, 12, 0 to give us that line. And for wire 2, there are 4 points. The first one being 0, 0, 0, so they share a point. The second one being up here at 0.543, the second one 0.7573, and then they share the same endpoint over here. And then I also have a third wire modeled off to the right. So one thing to notice, looking at wire 2, is that I've used 4 points to approximate this curve. You can see the difference if I go and I disconnect one of those points in what the curvature looks like if there's just 3 points. And so, like I said, when you're measuring your own models, the thing that you want to do is use the least number of points possible to get the curvature you want. And that's generally going to be either 3 or it's going to be 4. When you use 4, it's how you get a curve that's a little bit flatter like this, and with 3, it becomes a little more steep and a little more arced. So if you'll remember, the way we generated the sticks was by figuring out which parts of the domain of this curve we want to inhabit with the sticks and how many sticks. So if I go and I get an evaluate curve, and I feed it wire 2 and an input from 0 to 1, right? You'll see I get, my pink point is moving there. And if you remember, the reason why sometimes this happens, why even at 1 it's not going all the way to the end, is we haven't clicked reparameterize. The domain of that curve is probably set up by default to be its length, 0 to its length, as opposed to 0 to 1. So reparameterizing is just the way of telling Grasshopper, okay, let's all agree that 0 is the beginning, 1 is the end, 0.5 is the middle, etc. So if we did the same for wire 1, remembering again also to check reparameterize. Right? So what we did before, when we simply evaluated it like this, was we found that we could draw one line really easily. That would be the line that is the center line of our stick. But what we're trying to do is figure out a way to draw a series of lines. So we're going to divide up that curve not by using the divide curve, which we've used in the past, but by actually creating a domain that we can control and dividing up the domain, because that will give us a little bit more fine-grained control over how we place the sticks. Right? So as we said, right, the domain of this curve is set to be from 0 to 1. And here, if we go to math and domain, the default values are 0 and 1. And if we go to sets, sequence, range takes as its input a domain and a number of steps to divide that into. So the input to that is going to be our number of sticks. So let's call it num sticks. So we can set that up with a slider. Let's say we want between, I don't know, 2 and 25 sticks. Right? And once again, you remember if we divide it up 2 times, it's going to give us 3 numbers. So we're just going to go and add an expression x minus 1. So that the output that we get is a series of, in this case, 10 numbers, starting with 0 and ending with 1. And if we use that to feed into our eval, right, you can see that all of a sudden now we have 10 numbers. But just like when we did the divide, it's starting at parameter 0 and going all the way to parameter 1. So we can fix that by changing the input domain here. And let's call this min t and max t. T by convention is the parameter for a curve. We can add a slider. We just need to make sure that our maximum is greater than our minimum. Right? So here you see we're getting 10 points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, starting somewhere around, we set it this way, the 1/4 point, and ending somewhere around the 3/4 point. Right. And so what we need is a similar way to evaluate the other curve. Now, we could use just the same parameters, and then what's going to happen is our minimum and maximum are going to be the same for both, but maybe we don't want that. Maybe what we want is to have a separate domain for the top, but probably we want to keep num sticks to be the same for both, right? That is, we want the same number of points. So we let one slider control both num sticks parameters. Actually, what I'm going to do is just, there we go. But we have 2 different sliders that control 2 different ranges to feed our eval. Right, so in this way, we can set the range on the bottom one to be different than the range on the top one. Right. Now this gives us a series of center lines for our stick, but the other thing we did was we said, hey, you know, when you're modeling this with wood and wire, normally the sticks extend beyond the wires. So what we did is we used the extend curve, and we just set a standard extension past the wire. Let's call it extension past wire. And we can hook that up to a slider, which will be the same at the top and the bottom. So now the last thing we did was we wanted a way to model the sticks. So this is the center line, and what we need is a way to model the sticks. So first of all, let's dump this to a parameter and call it stick center lines. And next, what we did under analysis, perpendicular frame. It's kind of like evaluate curve, except instead of giving you a point, it's going to give you a plane at whatever parameter you specify. And the parameter where we want our plane is at 0. Let's remember to reparameterize these, even though 0 is always the start. So the nice thing about that plane is that we could use it to make, for instance, a polygon. And we know the inputs to the polygon give you a radius, they give you a number of segments, and that's the number of sides. So by default, it's a hexagon, but we know that we have square profile sticks, so we're going to say 4. Let me turn off the preview on the frame. And let's, so that radius is actually the radius that the square is inscribed in. So you could do a little bit of math and figure out what size the squares are, but I'm just going to approximate. That looks pretty good. And so the last thing we did is we turned, if you remember, that square into a surface so that when we extrude it along the line, we get a solid extrusion. And I can't remember where it is in the menu, but the what you want is the boundary surface. So in order to get the vector for the extrusion, what we did was under curve analysis, somewhere in here, where is it? Endpoints. I'm just going to cheat. Double click, endpoints. This gives you a point at the start and the end. And here under vector, we can create a vector from 2 points. Start point to the end point, and we can use that vector to extrude our surface. So there we go. I'm going to make this a little bit smaller. And I think I'm going to go back and adjust my domain at the top wire. And maybe I'll go ahead and add some extra sticks. So now maybe what you want to do is you want to have another series of sticks that's connecting from the top wire to this wire down here. So we're going to do basically the same thing, right? We have a domain and we have a range that we're going to use as our to create a series of points. We're going to evaluate wire 3. And remember to reparameterize it. We're going to use the same number of sticks. You don't necessarily have to, but I'm going to. And then we're going to create a line. From right now, it's from, see, that's the bottom wire, that's the top wire. Now, right now, since I'm using the same function here to evaluate the wire 2, I'm using exactly the same points, right? If I change these numbers, you can see that my new lines are also changing. So what I may want, actually, is I may want to copy that and connect up my wire 2 to a new evaluate with a new set of minimum and maximum. Right, and if I shift these over, you can see that I'm getting a new set of points there. And that's useful because now if I connect that to my lines, I can start to model what would happen if I have a second set of sticks that's weaving in with the first set of sticks. Right? So up here is my, my new stick center lines. I'm going to copy actually all of this as well and bring it down, because I'm going to use, there we go. Right. So now I'm using the same extension past the wire that I have up here for everything. But the difference is now down here, because I've added a new domain. That's the one for my bottom wire, actually wire 3. And here is the one for wire 2, but wire 2 as it's used to construct the second set of sticks. Right? So if I highlight those, you can see that I have 2 sets interweaving through one another. Now the last thing that I could do, if I want to bake this, for example, is I could take wire 1 and wire 3, oops, I didn't hold down shift, and wire 2. And I could feed all of these to the pipe component. And I could set up a much smaller radius so that I can give them some thickness. And I can, and then I could go ahead and I could bake all of this geometry. If I want to, I could bake it onto separate layers. So we can call that wires, and we could call this sticks. Could even actually call that sticks 1 and sticks 2. And now we have some geometry that we could use to start to create drawings or renderings or whatever we want. And it's an easy way of starting to think about how you might deploy sticks into your wires to start creating surface.